If we think back to that tree problem where my dad took the measurement of a tree using trig, he actually counted off the steps to the base of the tree. And when he counted off the steps to the base of the tree, he saw that they were 13 yards. And then he looked at the angle on his phone and measured the angle to the top of the tree, and he measured that to be 72 degrees. When we think back upon that, we found that height of the tree to be about 120 feet. And that was using trig. Now with that same exact problem, I wanted to use it, and I wanted to find the height of the tree, but I didn't like his method. I felt like there was an easier method. So I'm just going to draw the tree again. So if we take our tree, and with the tree now, I actually ranged the distance to the bottom of the tree. And when I ranged the distance to the bottom of my tree, by the way, when I'm saying ranged, I actually took a rangefinder, like we use in golf. And I ranged the distance right here, from the base of this tree to myself. I ranged this to be 16 yards. Then I took my rangefinder, I pointed up to the top of the tree, and when it was at the top of the tree, back down to my point, I ranged this to be 43.1 yards. Now you might say, Mr. Spang, that doesn't help me. I need to find the height. I need to find this distance right here in orange. I need to find my height. That's my question mark. I actually need to find that in feet, and you ranged everything in yards. Well, that's okay, because there's a nice formula, a squared plus b squared equals c squared. I'm sure you've heard about this, and it's probably a review, which is great. But I'm just going to write that up here. A squared plus b squared equals c squared. We're going to come back to that, actually. But in the meantime, we can look at our drawing. We can actually see we have givens. So this could be an A, this would be a B, this would be our C. So for our given, we have A equals 16 yards. Our C equals 43.1 yards. Now we look at our unknowns. Our unknowns is our height, or our B. And we're actually looking for this one in feet. That's what we want our final answer to be. We have an equation already, right here. Then all we have to do is substitute, solve, then evaluate results. So if we actually look at that and we just think about it for a second, we're looking for B right here. We have C, we have A. So I'm going to substitute in, or I'm going to at least rearrange the equation first before I substitute. So B squared equals C squared minus A squared. Therefore, B is going to equal the square root of C squared minus A squared. Now I can substitute in and solve for this. So B, which also equals our height, by the way, equals the square root of 43.1 squared minus 16 squared. By the way, this is all in yards squared. Now I plug this in, we get our height, which equals, I think it is, yeah, it is, square root of 1601.61 yards squared. We take that square root and we solve it, and we get our h is going to equal 40.02 yards. Now we're still looking for it in feet, remember? And we know that there are 3 feet in every yard, so our h is going to equal 40.02 yards times 3 feet per yard. Therefore, our height is going to equal 120 feet. Hey, that's what my dad got too. So there's different ways of doing it, and I thought that was a whole lot easier. I could just plug that in my calculator. It's like one step, boom. I don't have to think, so cut, toe up. So there's different ways to do things, and as this unit goes on, actually, we're going to be doing even more labs, kind of like Save the Bear, where there's plenty of methods to do it. There's plenty of equations that would work, but maybe one or two equations clicked for you. Or one or two equations were going to take a lot longer. Or maybe a couple of methods were just like, oh, this is fast, this is easy, I can just boom, 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 and get it right every time. So with different givens, or different unknowns, you can do it different ways. And if the experiment's left up for you to do, you can pick what unknowns or what givens you want to collect data for. And sometimes collecting data in one way versus another way is significantly faster. So, I'm actually going to, I have a little video clip of this tree falling now. And when the tree fell onto the ground, it was very large. And once it was on the ground, we could actually measure it if we wanted to. And it was about 120 feet. It actually measured up to be about 114 feet. But for using trig or using a squared plus b squared equals c squared, Pythagorean theorem, it's pretty close. Then we can even put that in our evaluation of results. My prediction was about 120 feet before I even did these problems, before I went out and measured it with my rangefinder, before my dad looked at it with the angle. I guessed about 120, and so did he. So you can even say in your evaluation of results, this matches with my prediction. My final answers, my units are correct. Check mark, check mark. And when you do all of that, that's how you know your answer is valid. So.
Here, kid. Nope, nope. More. Uh-oh. There you go.
It's gonna snap. Go.
It's coming. Oh, it's coming. Alright, get out of here.
Now that we looked at the example problem with that tree, we're going to move on to not just Pythagorean theorem, a squared plus b squared equals c squared, but we're going to move on to adding and subtracting vectors. What does adding and subtracting vectors have to do with a squared plus b squared equals c squared? Well, it's actually simple. The a and b are actually components, or what we could have thought of as components. So, if we actually look at this, I'm even going to draw it on here. A squared plus b squared equals c squared. What that meant was we had a triangle where this was our c, this was our b, and this was our a. And with a squared plus b squared plus c squared, we're looking here, our b and our a were our components to our c. So how does that help us, or how does that make us move forward? Well, when we're looking at this first question, by the way, what is components? What is a vector, first off? A vector would be something like velocity or acceleration, where there's a magnitude and a direction. When there's a magnitude and a direction, that's going to be a vector. Now, what's something scalar? Speed is scalar. That's where you just look at your speedometer, gives you just a magnitude. So our magnitude is our number, and our direction would be like north, east, south, 20 degrees north of east for this first one. So if I draw this one, what we're having us do in the first example, 1.5 centimeters. So I'm just going to draw a coordinate system right here, where this is east, south, west, and north. Now where would 20 degrees north of east be? Well, if I go towards the north, 20 degrees, that would be 20 degrees. Now what I'm going to do is I draw my resultant vector 1.5 centimeters long. So I'll take a ruler and a protractor, and I'm going to see that this is 1.5 centimeters long. So what is that? How can we show an arrow is both magnitude and direction? Well, first off, we see what direction is by what direction it's pointing. So we got to put our little arrow there. Got to put this little arrow point. Now, how do we know the magnitude? Well, guess what? If we look at an arrow this big, or we look at an arrow this big, or we look at an arrow that big, what's the differences? Well, the difference in these is the length. Which one would represent the greater magnitude? Yeah, the third one's going to represent the greater magnitude because it's the longest arrow. So when we look at length, that's going to tell us our magnitude. And we can also say this for speed, or velocity rather. When we draw a longer arrow, that means it's going faster. Or with acceleration, it means the acceleration is greater if that arrow is longer. And then we have our direction. That's when we look at our protractor. We use our protractor to measure that angle right here at 20 degrees. We have our magnitude of 1.5. Now we can look at our Pythagorean theorem, a squared plus b squared equals c squared, right here. And we look at that and we see what? We see our components. So we can see our x and y components. So a squared plus b squared plus c squared, here's our c, here's our a, here's our b. So a, b. Now, we can't find a or b just using a squared plus b squared plus c squared, so we got to remember back to our trig. So remember back to our trig, we have no, not sa, but ka, toa. And which ones do we need to use? Well, if we have an opposite that we're looking for, and we have our hypotenuse, we're going to use cosine. And if we have an adjacent, we're going to use sine. And if we have an adjacent, that's when we're going to use our cosine. So our A, in this case, will be adjacent. And our B is actually going to be our opposite. And our theta is going to be right here, which is 20 degrees. So when we would look over here at our A, this would be for B, and this would be for C, by the way. That's just what the ABC mean. When we look at that, we can figure out our components. So if we're looking for A sub x, what's that mean? It means this x value right here, our x direction, our x component. So if we're looking for adjacent, we know we know cosine is adjacent over hypotenuse. So cosine theta equals adjacent over hypotenuse. We're looking for this adjacent. All we have to do to figure that out is we take our hypotenuse and multiply it across the other side. So we can even look at that and we know what all of those are. So cosine of 20 degrees, by the way, we make sure our calculator is in degree mode, times our 1.5 centimeters equals our AX. So you just plug that into your calculator and see what you get. And it's as simple as that. And you keep moving that on. And by the way, our components, less than or greater than our hypotenuse? Should be less than, right? Okay. So you make sure that these numbers are always less than this number. Because that's how it works. A squared plus B squared equals C squared. Okay. Now we go from there. We look towards our resultant components. What does that mean? Well, let's just say, let's give a random value for a of x. Let's just say a of x equals 3 centimeters. Let's say b of x equals 2 centimeters. Let's say c of x equals negative 1 centimeters. By the way, what's the negative mean? It means direction. So all this means right here is instead of it going to the right 1 centimeter, it's actually going to the left 1 centimeter. So when it says adding and subtracting components, you're really just adding a negative. It's just direction. So when we add those together, we have 3 plus 2 plus a negative 1. These are all in centimeters, equals our Rx. So Rx is going to equal 4 centimeters to the right, or it's positive. Either one works. I prefer positive, negative, so we can get into that habit, getting away from the arrows more so. Now let's say my y components. I'm just going to make up numbers once again here. Let's just say this is negative 3 centimeters. This is negative 2 centimeters. This is positive 4 centimeters. So when we add those together, so negative 3 plus negative 2 plus 4 centimeters, that's going to give me my Ry. My Ry in this case would actually equal negative 1 centimeters. Now for our y direction, what does a negative mean? It means down. So we have something down. So if we go down here, when it says graphically draw the resulting vector, we're actually going to do, we're going to go up here. We're going to see this says positive 4. It says negative 1. So we're going to start here. By the way, when we draw our arrows, we're always going to go end to tip. That little arrow heads the tip, then end to tip. So tail to tip, always. And then we'll draw our resultant vector in between them. So that's all we have to do. So if we draw our vector 4 centimeters out this direction, put our arrow on it. Now we go 1, so that's right here. That's this guy. Now I'm going to use a different color. I'm going to use green for our y. I'm going to go down 1 centimeter. I'm going to label these, by the way. 4 centimeters, 1 centimeter. And I'm going to draw my resultant vector in yellow. Now what I can actually do, if I draw those to scale, I can take a ruler and I can actually measure this out. And what I measure out there is my magnitude. So I can easily just tell you what my magnitude is, a number right here. My magnitude is that distance. And then what's my direction? Well, I grab a protractor out and I measure this right here. This is my theta. And it's going to be some degrees. And what is it going to be? We're going, here's east, this direction is east, and we're going down, so south of east. So that's what you do, and you can just easily draw them. But sometimes drawing them is going to take more time, but it's always a backup plan. Might be you're evaluating results from Guesser, just do a little picture and see if your things are lining up and it makes sense to you. But now we're going to look it back towards Pythagorean theorem. We're actually going to find the magnitude and direction of r that way. So if we know it's 4 centimeters is, we'll just say A in this case. We know 1 centimeter is B. I can actually, and we're looking for C, so 4 centimeters squared plus 1 centimeter squared, square root all of this, that is going to equal our C. So the square root of 17 centimeters squared equals C. I'm not sure what that is off the top of my head, so give me 1 second to plug it into a calculator. You can do the same right now, plug it into your calculator. By the way, what should it be? It should be somewhat close to 4, because this is just 1, but it has to be above 4. So when I typed in my calculator, I got 4.12 centimeters. Check, that works. Now write down why that check mark's there and why that works. So then I also have to find out my direction. Well, I can look up here to my triangle. I have my opposite, I have my adjacent, I have my theta right there, and I know, I don't know what just happened, that's for sure. And I know tangent of theta equals opposite over adjacent. So I know theta is going to equal my inverse tangent times opposite over adjacent. So I can plug that in, and all I get would be my opposite being 1, my adjacent being 4, 1/4 tangent inverse equals my theta. I plug that into my calculator to get 14 degrees. So my resultant vector, I can actually write that out as 4.12 at 14 degrees south of east. And there you go. That's how you get your total vector. And you're just going to continue this down throughout the worksheet and working on that. And the cool thing too is when you look at velocities, velocities have a magnitude and direction, so it's the same thing. And you can just continue on that pattern. It doesn't matter what it is. If it has a magnitude and direction, you can find it. And by the way, that resultant vector is going to be the change in. What's acceleration? Acceleration is the change in velocity over time. So there you go. You just found your acceleration down here. So just continue that pattern as you go. We're going to work on the rest of this worksheet as time goes on. You can ask myself or Mr. Brindle for any questions you might have.